I would like to solve this question. Find a vector that has the same direction as the vector negative 2, 4, 2, but has the length 6. Okay, so first, let me see what the length of this vector is. Let me give you a recall. The length of a vector ABC is this. I show it by the absolute value of the vector, and the length is square root of the first coordinate square, second coordinate square, and the third coordinate square. Okay, so this vector, just assume that this is the vector, negative 2, 4, 2, the same direction. The length of it is absolute value of negative 2 square plus 4 square plus 2 square. So this is 16 plus 4, 20. So this is 24, square root of 24, which would be square root of 4 times 6, 2 square root of 6. Okay, now I'm looking for a vector that has the same direction. Okay, so let's find the unit vector in the direction of that. What is a unit vector? Another recall. So the unit vector in the direction of a vector v, for example, is, okay, so I have the vector v, and I'm gonna multiply it by 1 over length of v. In that case, I get the unit vector in that direction. Okay, so now I'm looking for the unit vector in the direction of this vector. So what I need to do is to have the scalar multiplication of the length of the vector negative 2, 4, 2, and I'm going to multiply it by the vector itself, negative 2, 4, 2. So this is 1 over the length of this vector is 2 root 6, and I'm going to multiply it by the vector itself. So I get what? I get negative 2 divided by 2 root 6, 4 over 2 root 6, and 2 over 2 root 6. So if I simplify that, I get negative 1 over root 6, and I get 2 over root 6 and 1 over root 6. Okay, what is this vector? This vector is a unit vector. If you find the length of this vector, you see that the length of it is 1. And it is in the same direction of the vector. So this is the unit vector in the same direction. I'm going to call it like u. This is the vector u. Okay, of the length 1. And in the direction of the vector. Why it is in the direction of the vector? Because I multiplied the vector by a positive scalar. So this positive scalar doesn't change the direction of our vector. And so I found the vector in the same direction. Now I want the length of it to be 6. So what I need to do is to write 6x. So I'm going to multiply 6 by the vector u, and I get what? 6, negative 1 over root 6, 2 root 6, and 1 over root 6. So this is negative 6 over root 6, 12 over root 6, and 6 over root 6. Too many 6. Okay, if you simplify it a little bit further, so I'm gonna just as a little algebra. Negative 6 over root 6, I'm going to multiply top and bottom by root 6. And in that case, I get negative 6 root 6 over root 6 squared, which would be just 6. These two would be cancelled, negative root 6. So if you do a little bit of algebra, you get this. And then I'm going to do the same thing here. So let me do it. Let me erase this one just as a practice for a little algebra. So it is 12 root 6 over root 6 root 6. So it would be 12 root 6 over 6. It would be 2 root 6. So 2 root 6. We're going to do the same thing, and the last one would be just root 6. Okay? So this is the vector that I was looking for. It has length 6, just because u was the unit vector with the length 1. I multiplied by 6, so 6u has the length 6. And it is in the same direction because I multiply 6, positive number, and then for u, I multiply 1 over the length. Length of any vector is a positive number. So everything would be in the same as the original vector.